let me show you the roadmap of our presentation. It consists of three parts. The first part is PDF structure recognition with iText. Note that I have highlighted with intentionally because I want to underline that currently iText does not contain high-level API for structure recognition, but in this presentation I want to show you how you can create your own structure recognition processor on the top of current version of iText library, and I want to show you that you can do all this just in a few steps. Here I will provide a little bit of theory combined with exercise to show you how to do this. When it's done, we will go to real customer example where all the ideas explained before come to real customer's application. And finally, we'll go to the last one chapter, which is called PDF structure recognition in iText, where I very basically tell you what we want to see in PDF structure recognition in future versions of iText. Let's start. PDF structure recognition with iText. I would split this process into three parts. The first part is parse PDF, where we actually parse the PDF document. The next one is apply user input to parse data. I will explain what it means a little bit later. And finally, we need to analyze parse data and finally build structure. So our first step is parse PDF. I'm sure you already know how iText is powerful when you want to create PDF document from scratch. When you add paragraphs, tables, lists, iText can do it perfectly. You can merge, split PDF documents, you can even sign them digitally, but not a lot of users know that also iText contains very powerful parsing API, and I want to show you how it works. Well, actually I think that's because parsing API described in the very last chapter of iText in Action book. So basically what user wants to see in normal PDF parsing API. Users wants to extract images and text item from PDF content. User wants that those images contain all the graphic state. Well, anyway, all the maximum possible information related to extracted images and text items. And in some cases, user may want to specify some additional actions to extract images and items. And I want to show you that with iText you can do it only in a few lines of code. Let's see how it works, and let's try to parse this page of our favorite company's book. It's called iText in Action. You can see that, well, the layout of this page is not very complex. I did it intentionally. But anyway, you see that page contains of a lot of paragraphs of plain text. There is a heading, there is an image and image caption, and also at the very top of a page you can see page header artifact. So this is the first lines of code, but before I start explaining what it means, I want to say that our goal, our goal is to parse the PDF document, and we want to highlight all the parsed items in different colors. For example, we want to highlight all the parsed text items in blue and image items in red. So this is our first part of code, and in a first line, well, in this presentation it looks in 2 lines. We need to initialize PDF reader. PDF reader is a very basic iText structure which gives you an access to low-level PDF structures. It's very easy to initialize it. You just need to pass a file name to a PDF reader constructor. When reader initialized, we initialize parser, which is called PDF reader content parser in iText. Probably in your version of iText we will make the name shorter. To initialize PDF reader content parser, you have to pass the previously initialized reader. The next line actually does all the parsing. So you can see that I call process content method at previously initialized parser, and this method takes two parameters. The first parameter is a number of pages we want to parse, and the second parameter, this is our own implementation of render listener. Render listener is the standard iText interface, which I will explain how to work with this in a few slides. But now I just can say that all the main magic of parsing is concentrated inside this my render listener class. Finally, we want to highlight the parsed items. Highlight method is not a standard iText method. This is the method I have created just for our presentation. I'm not going to provide the code of this method because it's not very interesting for our presentation, and I want to make the presentation more compact. That's why code is not provided. But the main thing you should see here is that first parameter, which method highlight takes. This is items from render listener. This is instance of my render listener, and items actually are items which have been parsed from PDF page content one line ago. Finally, we should close the PDF reader. Now let's return to implementation of standard iText render listener interface. To implement this, you basically need to implement two functions, which is called render text and render image. When parser goes through the page content, it calls these methods. Render text method is called when parser reads out text item from PDF page content, and render image method is invoked when parser reads out image from PDF page content. It can be either inline image or regular image. Text render info and image render info parameters, which are passed to this method, contain all the maximum information you need. For example, text render info contains full graphic state, full text state, and of course it contains the actual text content of a text item. And image render info also contains full graphic state, and it contains a link to actual image resource. In our presentation, methods are implemented very simple. They just convert text render info and image render info to item. This is a structure I have created just for this presentation, and when the item is created, it's added to item list. So that's why when the page is parsed, we can get item list from our implementation of render listener. This is how our own class item looks. This is simply a rectangle. This is a bounding box of extracted item, and additionally to item, text item contains font name and font size. And the final piece of code in this part of presentation is a getColor method, which is used by highlight method. You can see that if item is an image item, then method returns red color, and if item is a text item, then method returns blue color. So on this slide you can see that we have successfully parsed the page content, and we have highlighted all the parsed items. You can see that all text items are surrounded with blue rectangles, while image is surrounded with red rectangle. Now let's go further and try to apply user input to parse data. So why do we need user input? First, well, it helps structure recognition processor to analyze parse data. It helps to make a distinction between text styles of plain text, text styles of heading, of captions, etc. So for our page, we need to define text styles for plain text, heading, and caption, and we need to define page artifact areas. So let's add some input, and this is a first input, first user input, I just open this document in Adobe Acrobat, and with measure tool I have measured that artifact area occupies topmost 48 points of a page. So we are defining that the topmost 48 points is page header area. Now again with Acrobat tool we know that that the heading is written with Franklin Gothic font of 10.5 size, and image caption is written with the same Franklin Gothic font but with a different font size. It's 8 points. And finally we have several plain text areas which actually consist of two different fonts. A new Baskerville font of 10 points for regular text, and a Courier font of 9.5 points for code example injections. So to apply user input styles, we need to redefine getColor method a bit. I'm providing this code not in pure Java but in pseudocode to make the slide more compact. Otherwise I didn't have enough space on this slide. You can see that for image item the code stays unchanged, it's grayed out, but for text item it's changed. Here is a check: if item occupies the topmost 48 points of page, then getColor method returns red color. Otherwise it asks text style map for color. Let's have a look how text styles map look. This is simply a map which maps text style of Franklin Gothic font of 10.5 points to orange color. It maps text style of Franklin Gothic font of 8 points to green color. It maps text style of new Baskerville font of 10 points and text style of Courier font of 9.5 points to blue color. And finally, this is how text style looks. This is also our own structure. It contains only font name and font size, and also it contains methods equal and hashcode in order to be key in HashMap collection. And you see that we have correctly applied our colors to this page. You can see that page header artifact is now colored in red. You can see that all the plain text remains blue. Heading is orange. Image is still red because we didn't do any changes there, and image caption is green. And now let's go to our final part of this process. This is analyze data and build structure. So what should we do first? First we need to sort all items in natural reading order. I believe you know that items can appear in PDF page content chaotically. So that's very unstructured, and we need to sort them. Then when the items are sorted, we want to combine them into lines. My original piece of code has been a little bit adjusted, and you can see that I have added sort call just after parser process content method. The method sort takes a list of parsed items and returns a list of sorted items. I'm not providing a listing of sort method here, but it looks very simple because all the items have their rectangles, and we just sort them from left to right, from top to bottom. And the next line is getLines, which takes a list of sorted items and return a list of lines. Again, in purpose to make presentation compact, I'm not providing here the listing of getLines method, but if the items are sorted, if all of the items have their rectangles, it's quite easy to combine all the items into lines. We just need to see that they have more or less same vertical coordinates and the items belong to the same line. And I have adjusted highlight method a bit so that it takes not a list of items, but a list of lines. And this is our result of combining lines. You can see that the page is highlighted in the same way, but all the items, all the text items are combined into lines. And now we want to combine those lines into more common structures, such as paragraphs, headings, and captions. But in our example, headings and captions are single lines, so we have nothing to combine here. So our goal is to combine all blue lines to paragraphs. Yeah, so this is a get structures call, which is also my own method, and it does a lot of interesting logics, but again, in purpose to make the presentation compact, I'm not going to provide the listing here. The method analyzes adjacent lines, and it analyzes lines in common, and after this analyzation, it makes a decision if adjacent lines belong to the same paragraph or not. So this method takes a list of lines and it returns a list of a list of a list of an items, which is actually a list of lines, which is actually a list of structures. And again, I have modified highlight method a little bit so that it takes a list of structures, and we are passing the structures to this method. Yeah, and finally we see that that all the structures are correctly highlighted here. Page header artifact, heading, and caption remains single-lined, but here you can see 4 properly recognized paragraphs, which are bounded with blue rectangles. Yeah, so at some point we are done with parsing and structure recognition, but I can predict a lot of questions because not many aspects of this exercise has been exposed. So this slide probably predicts some of your questions. Yes, not all methods are exposed in purpose to make the presentation compact, but if you are really interested in how this method looks, I can share my code, no problem. The structure is recognized, but we do not create tagged PDF. Here we only highlight elements by structure, by color. This is done to make the presentation more visual. To create a tag structure, you just need to replace highlight method with, for example, your self-implemented create tags method. Well, a highlight method. What highlight method actually does, it modifies page content structure, adding rectangles to it. And absolutely in the same way, you can modify the page content, adding tags to it. And it's absolutely not a problem with iText to generate logical structure of PDF documents. Of course, this solution has some limitation. More complex layouts like multi-column text or tables are not handled in this example. You will have to think a little bit more on get structures method, which does all the very interesting logics here. And of course, if plain text, headers and caption use the same styles, output can be incorrect. So structure recognition processor missingly can think that that header is a plain text or caption is a header or something like that. But my general goal was to show you how you can implement. My general goal was to show you that iText is a perfect start for implementing your own structure recognition processor. So that's, and hopefully I did it more or less. And now we are moving to a next part of our presentation. This is more fun because this is a live demo, and here I want to show you how we have implemented all these ideas in a real application. I think about a year ago we have finished work on a project for Global Submit. This is a company Bruno already mentioned in his first presentation, and this is a healthcare service provider, and they have created an application which is called Link, which allows users to make thousands of plain PDF documents, absolutely non-interactive, make them interactive, meaning add links, add bookmark trees, etc. And I want to show you this presentation in order to show how we implemented some of the ideas I have explained before to real life. Now I will start the application. You don't see it. Just a second. So this is an application which is called Link. At the left side of application here, you can see a list of PDF documents you want to change. The top part of application is occupied by the actions which are to be done over these PDF documents, and the bottom list of application is an embedded PDF viewer which helps you to preview the results of our operation, or in some cases it is needed for extraction text styles from PDF documents. The first feature I want to show you is update link appearance. I think that you probably recognized the document I want to place. I want to play with. This is developing plugins and applications specification from Adobe, and you can see that it contains a very big table of content, and these are each table of content item is a link, but the links are written in black color, so for customer it's not it's not very understandable that it's easy that it's really a link. So to improve users' life in this area, we can select a new link appearance. For example, we want to change link color to red, and well, line color to blue, line style to underline, and after that I want to update the current PDF document, and so my operation is configured, and now I'm clicking execute button. It's working. It's still working.
The links are link objects. So what you're doing is you're transferring not the links themselves, but the text underneath them.
Yeah, right. We extract text by rectangle from a page content, and we change its color.
The link itself is the same.
Sorry?
The link itself, the link object itself, is remain the same annotation.
Yeah, it's annotation, but yeah. In this case, I just want to show how to that application can extract text from page content by link rectangle, and after that it changes its color. So you may ask, where is structure recognition here? But actually it exists. By rectangle we find links in a document. This is very similar to what we did for page header artifacts. Yeah, you can see that the links are properly colored here, and yeah, links still working. This was an appetizer, and that probably was not the most interesting example. Two next examples, I hope, much more interesting. The next one I want to show you is how to create bookmarks tree by text styles. I'm opening this document, and I have removed all the interactive features from this document. You can see that it does not contain bookmark tree. And if we go to table of content, for example, you can see that these are not links. This is a plain text. So how can we create bookmarks tree just by text styles? I want to navigate Sorry, I have removed all links from table of contents, so I cannot navigate very fast. Yeah, so I want to make preface my bookmark, and it means that well, I want to make all the headers with such style bookmarks. I'm selecting text, and I should click this button, which is add by selected text, and the style is immediately extracted from PDF document and copied to this window. And if you have a look at table of content, you can see that preface, introduction, understanding plugins, and a lot more are the headers of a same level. Now I want to I want to select apply for current document, and I want to try to do it. It's not very fast because the document has a lot of pages, and the second reason is that because notebook is not really fast. Unfortunately, I don't see. Just a second. Oh, it's not responding. Yes, you can see that processing occurred successfully. But I really don't see any bookmark here. So it lies. Give me one more chance. Let me try to select this one. Maybe Just a second. No, sorry, I don't see bookmarks here. Probably something went wrong. Well, anyway, let me try if the next one feature works. The next one feature is even more nice. Hopefully, it will work. It will create bookmarks and links from a plain table of content. You can see that the document contains no any bookmarks, and here is no links, but it contains very good table of content. So yeah, what shall I do here is to specify the first page of table of content, which is actually 3, and I want to specify the last page of table of content, which is 10, and also we need to specify top margin and bottom margin to remove page header and page footer artifact. These are 1 inches. You can see this yellow line means this area. And if you want to create links from links for the table of content, we should choose this option. And you can see that table of content items have different levels by indentations. So this will be our rule, which we want to create hierarchy by indentation. This rule will be used for creating bookmarks. Okay, I'm crossing my fingers. Oh yeah, it works. You can see that it says the document is processed successfully, and this time it's true, it's not a lie. You can see that bookmarks tree is properly created, and it's absolutely workable. I can click here and then immediately jump to Acrobat Core IP objects. So you can see that we can easily navigate here. And also the links have been created for each table of content items, which also perfectly works. Yes, so give me please a chance to rerun the application. Probably I will be more lucky with this. Raf, can you help me? Where's the application? It's yeah, this one. I'm choosing a folder. I'm opening the document. Well, you can see that it already creates the bookmark tree, but if we generate bookmarks tree again, then it's created from scratch. So let's go here. Let's try to select this text style and copy it here. I want to apply this to current document. Now it lies again. It says that process occurred successfully, but you don't see any bookmarks here. Yeah, we will submit back to ourselves. But I think it's something environment dependent, because on my PC it works, but unfortunately this presentation devices does not have HDMI cable, so I have to change the environment. Well, anyway, we have implemented some very interesting features, and this application contains a lot more PDF related features which has been done with iText, but they are not related to the topic of our presentation, so I'm not going to show them right now. And finally, the last slide is PDF structure recognition in iText. So this is our plans on how we see PDF structure recognition in the future version of iText. Of course, we want the structure recognition API to be a native iText API, and we want to build it on the top of existing PDF parsing API. We want to try to minimize user input for structure recognition. For example, we want to make it so that our structure recognition processor may guess some styles for heading, for captions, etc. We want to add support for more element types such as list tables and table of contents. We want to add support for more complex layouts such as multi-column text. And probably it would be nice to add a possibility to export recognized structure to a different output format such as Microsoft Word or plain XML or something like that. So that's all. Sorry for issue with live demo. Thank you for patience. If you have any questions, please ask. So,